Hey, welcome to Security and GRC Decoded. I'm Raj Krishnamurthy, your host, and we have the awesome, amazing, and multi-talented, multifaceted Josh Bressers with us today. Josh is responsible for security at Anchore. He's a hacker, host of a Hacker History podcast, and has led security and products at Elastic and Red Hat. Josh, welcome.
I'm so excited to be here, Raj. Thank you so much for having me.
No, thank you, Josh. So let's get started. Josh, before we talk about you, what is one controversial opinion that you hold?
All right. So I don't know how controversial this is, but I'm of the opinion that no one will do compliance or security out of the goodness of their heart. That these things are generally second order functions, be it you have things like compliance or legal reasons, maybe your insurance is telling you have to do it, or if we make it the easy way. This is where something like Rust is one of my favorite examples, where Rust automatically comes with a bunch of free security, and people aren't using Rust for the security. They're using Rust for all this other stuff. It's just security kind of comes with it. And this is one of those things that I have the conversation many times where there are a lot of security people that think like, oh, people will do security because it's right. I'm like, I don't think so. I think people will only do security if you make them do security, or it's the easy default.
Okay, that's interesting. Can I call you the SBOM dude, Josh?
If you like. I mean, I would give that title to Alan Friedman, he's at CISA, and he definitely is like the godfather of the SBOM. But I do love SBOMs. I do a ton with SBOMs right now. I've got the company I work for, Anchore. We do SBOM management. We've got an SBOM generator, an open source tool called SIF that's like very, very popular. I head up a group at the OpenSSF called SBOM Everywhere, where we're trying to bring SBOMs into some of the open source world, which is that's a bag of snakes in its own right. But then I also I help out with various working groups like at CISA and kind of anywhere I can just to further SBOMs, because I think they're really cool and I really like what we can do with them. And I'm looking forward to the things we can't imagine yet that we're going to do with them someday.
Totally. So let's talk about you, Josh. How did you get started in security technology?
I mean, that's a long story, but I'll give you the very short version is I am a child of the 90s, right? I'm a gentleman of a certain age, we'll say now. But when I really started paying attention to technology, it was the heyday of these hacker groups. Like you had Cult of the Dead Cow and you had Loft, and there was all this new technology and open source coming out. And, you know, when you're a poor college kid, a poor high school kid, and you want a development environment, you want a Unix workstation, and you don't have, $45,000 to buy a Sun, all this open source, all this Linux stuff was really the thing to use and the thing to learn. And so I feel like I existed in this just like perfect nexus of like amazing security people that I really wanted to understand what they did and be like them. There was this open source universe that just I loved and it intrigued me. And I'll never forget is when I was very young, I would tell people I want to either do security work or I want to work at Red Hat. Like that's my dream. And I ended up doing security work at Red Hat. So I'm like, nailed that one.
Oh, that's beautiful. And so then you moved from Red Hat into Elastic. Is that right? And then
yeah, that's right. That was a lot of fun. So obviously Red Hat, I was at Red Hat during, we'll say, the heyday of open source, where we had a lot of conversations where people would be like, oh, that open source thing, I don't know if that's going to catch on. And I mean, I'll never forget, I had a boss at my first job that was like, you're a smart kid, stop using this open source crap. Like you're wasting your life. Use Windows is the future. And of course, being young and filled with passion, it's like, no, open source is the only way. It's we're going to win. And it did. I mean, thank goodness. But yeah, so and then Elastic was kind of when all of the big data started becoming a thing, right? Where we had the ability to ingest, gigabytes and terabytes of data and start understanding it and knowing what it was. And so, I won't say open source was boring, but I feel like we kind of figured out a lot of the open source challenges. So I'm like, big data, like that's where I want to go next. And so, yeah, I spent, I think, 6 years at Elastic and I learned an amazing amount. And even now I still run Elasticsearch in my basement. And anytime I see any data of any sort, it goes into Elasticsearch and we start poking around at it. It's really a lot of fun. I love it a lot. And then I would say kind of once the data thing, I got cut my teeth in there and I started figuring that out. I feel like the whole open source supply chain SBOM thing became, well, I'll say hip. I don't know if I'd call it the hip thing, but it is where my interest went. And so then when Anchore called, I was like, oh, this is it. Like I'm in.
So you're a Linux dude, you're a security dude, you're an SBOM dude, maybe a supply chain dude. Let me
Yeah.
ask, what is your opinion of the CrowdStrike Falcon? Can I dare to say the fiasco? What is your opinion of that?
It was a fiasco for sure. I mean, it's amazing when one company has such market share that they can just crash the world, which is bananas. I was actually, funny enough, I went on vacation the week after that happened and I was flying Delta. And I remember sitting my family down and I was like, we might not get to go anywhere. Like, we're going to find out. And I remember we got on the airplane in the morning and we flew to Atlanta. And I was like, we might be spending a couple days in Atlanta, like just to prepare everyone. We didn't, thank goodness. We were very late getting out of Atlanta, but we made it out. So it was good. But anyway, so the whole CrowdStrike thing, I think this is a really good lesson in the supply chain and safety universe is where I would put it. And I bring up safety because anytime you have a system that fails, this is something that there's a friend of mine, Thomas de Pierre. He wrote a blog post called "I Am Not Your Supplier," is kind of his claim to fame. But he also does a lot of safety work, and I've learned a lot from him, and I talk to him whenever I can about this. But if you look at failure of complex systems, it's never like one thing. There's always like 10 or 20 or a whole bunch of little things that all have to fail in their own spectacular way to come together. And CrowdStrike was very much this, right? How many times had they pushed out these sort of updates to the world, right? Multiple times per day. And we've never seen an incident like this. And it was, this combination of it was a very specific kind of update. It had a very specific test that wasn't checking this one thing that they did, and it all came together. And I think this is kind of one of those lessons that we can take as, GRC types, where you have to take a step back after an event like this and take a good look at it and say, like, how could we have made sure this didn't happen and make sure it never happens again? Because I can promise you that particular failure mode is never going to happen again at CrowdStrike, guaranteed. There are other things that could happen, but that one is certainly not, right? They know what they did.
So, what is your take, Josh? That is it? And I'm not trying to play blame games here, but is it Microsoft at fault or for opening up the kernel updates to vendors, or is it the vendor's fault, CrowdStrike in this case, for doing a bad patch resulting in a blue screen of death?
I mean, you can blame everybody. You can blame the people who are running CrowdStrike. Why were these organizations running software in this way that they weren't doing any testing on updates? They were just pulling this stuff in and deploying it. They didn't have the ability to fail over to something else. CrowdStrike, yes, certainly should not have pushed a bad update. I mean, that's a no-brainer, obviously. Microsoft's, we'll say, difficulties in working with these endpoint vendors in the way the kernel's accessed. Yeah, but again, this comes back to, remember when I said, when complex systems fail, like a whole bunch of little things go wrong. Those are all of the little things that had to go wrong in order for this to fail. And so you can definitely spread the blame all over the place. I mean, fundamentally, at the end of the day, the view I take on things like this, and this comes from my days at Red Hat, when we would ship a lot of open source software. If you ship it, you support it. So we can explain how everyone could have done different things. But I think at the end of the day, this is like, it's CrowdStrike's product. It broke. Yeah, you can blame everyone else, but like CrowdStrike is holding the bag at the end of the day, I think.
Got it. No, that's an interesting perspective. Do you think sandboxing techniques like if I can use eBPF as a sandboxing technique that we have on Linux, something like that could have not avoided, but at least can mitigate some of these issues?
I mean, probably everything I understand from what I've read says yes. But at the same time, like if you have a system that on boot is just instantly crashing or making things not work, it's not going to matter if it's sandboxed or not. I mean, if you have some sort of endpoint, protection running in place and it doesn't allow any network access, like who cares if it's in the kernel or eBPF? Like you've broke everything. I guess the one advantage is theoretically it might be easier to fix. Maybe, I don't know. But I don't think eBPF is necessarily the magic bullet that some may have claimed it was. We're just trading some problems for other problems. I think that the problems with eBPF are probably less horrific than when you're, like literally down in the kernel, but it's certainly not a silver bullet for this problem.
Got it. And so I think it brings us back to SBOMs, and for our users, listeners, what problems do you think SBOMs solve?
All right, so I'm going to define an SBOM first, just to set the stage here for anyone who doesn't know. SBOM, software bill of materials. And the idea being you have this document that tells you what is in a thing. It could be a computer can have an SBOM of all the software on the computer. You can have an application where, let's say, I'm getting, what we'll say, CrowdStrike from a vendor, and they give me an SBOM and it tells me everything inside of that application. Because as we know, nobody's writing all their code. You're using like 80, 90% open source. In every single public survey I've seen to date, the number is just amazing how much open source is out there. Like open source truly won. The dog caught the car, now what? But it's absolutely everywhere. And so the purpose of this document is to help convey what is in, like, what are the parts I'm using to build my stuff? And this is not a new concept. When you buy, let's say, a lawnmower, it's not uncommon at all that in the back of the manual, you have a list of every part they used. You have diagrams showing where the parts go. And of course, this is for maintenance reasons often that, oh, this screw broke. What kind of screw was it? Let's go buy a new one. And it's the same basic idea for software, right? Like why do we treat software as this magic black box that we don't know anything about on the inside versus saying, I want to know what's in the stuff you're selling me. And then we can use that information to do things like, say, when there's an incident with a log4j. We can say, do we have log4j running in any of our stuff? Have we ever had log4j running in any of our stuff? The history of this is what makes it really fun because these are JSON documents you can easily store. This kind of goes back to my whole Elastic universe. We can put them all into a system forever, and then we can query back and say, like, 3 years ago, what was I running in this application? Like, what was there? Was log4j there? And so that's part of the fun of this is you can go, way back in time because they're not huge documents. They're very easy to store.
Got it. And this, I'm connecting this back to your earlier comment on Thomas DePierre, right? And the I'm not a supplier article. So are the incentives stacked well enough? Because as you rightly said, we consume open source at an extraordinarily high rate, right? And are the incentives stacked enough in the open source community to build the right software security products? And how do we go solve if not?
I don't think so. The way I describe this is I say open source owes us nothing. These are people that have written software, they've put it on GitHub, they've added it to a foundation, they've done whatever. And if you look at every open source license that exists, at the very beginning in all capital letters, it says this software is provided as is. Like there are no guarantees that come with this. You are using it at your own risk, essentially. And I don't think it's on open source to secure open source. I mean, I'm not saying they're like running around trying to be insecure, but I think especially like Log4j, we saw this a lot where you had these like the Fortune 500 companies sending questionnaires to open source developers. And they're like, I work on this on Saturday afternoon. Like, I'm not answering your freaking questionnaire. Like you have people who do this, go figure it out yourself. And I think this is one of those instances of like, if you ship it, you support it. It is not open source's job to do your homework for you. Like you're using this open source. It is your responsibility to understand what am I using? And then at the end of the day, I have to deal with the fixes because I'm the one shipping product that contains this code.
Totally. And how do you see SBOMs fitting into this this notion of supply chain security? Maybe it will be helpful to first describe what is your notion of supply chain security and then how SBOMs fit into it.
I don't think anyone knows what supply chain security really is. Look, the way I kind of view it is when we go from a developer working on a thing all the way to that thing going into production, be it I'm selling software to you, I'm deploying SaaS, I've got an API running somewhere, there are stages along the way, right? Where you have a developer writing code, you have a developer pulling in open source dependencies, you send it off to CI/CD, you send it off to build, it ends up getting into the production system somehow. Maybe you're compiling code. There's all these steps along the way. And I think we've created these very intricate and complex systems over the years, and we just kind of gave them all a pass for a long time. I mean, you probably see this all the time in the compliance world, Raj, where the focus, the obsession is with the thing I've deployed at the very end, right? When you're going to get like your FedRAMP compliance, when you're getting your PCI compliance, it's historically simply focused on like the thing I deployed, right? It could be a complete mess over there to the left. We don't care because that's not what we're auditing, right? My report doesn't say anything about what's going on over there. And so I think this whole notion of supply chain security is starting to lift that curtain and looking everywhere. Now, at the same time, I think we're seeing, we've been talking about shift left for like 5 years now. And there's this obsession with what developers are doing, but there's also like a ton of stuff between developers and deployment that we're not paying attention to very well. I mean, and if you look at things like the XZ incident, you had the SolarWinds incident, those were like in the build systems.
Yep.
Who's talking about, sometimes I feel like this is madness because most of the successful supply chain attacks are happening like in the middle between developers and deployment, yet our obsession is with developers and deployment. And it's like, look at what's going on here. So anyway, back to your question. So SBOMs, right? This is where we can do things like we can take a snapshot of what is on the developer system. We can take a snapshot of what are the dependencies the developer is using. We can take a snapshot of like what's in CI, what version of the compiler did we use to build this stuff? Like if you ask most people that, they're like, I don't know, like GCC. It's like, no, that's not the version. That's the compiler's name. There are versions of it. And, same thing where once you start to deploy things, you can say like, this is what I deployed. This is what the system looked like I deployed it on. And then you can also like rescan it and say like, this is what it looked like today. This is what it looked like a week later. Why did all this stuff change? Nothing was supposed to change. And so that's really what SBOMs are giving you at this point is you take snapshots many, many times along the way. And now you're saving a reasonable size document versus like, let's say you're working with container images. If you have, a 1 gigabyte container image and you snapshot it 10 times, now you're storing 10 gigs. Now do that, 5 times a day and your storage costs get out of control. And so that's kind of the power of these things. Now, granted, we have a long way to go. We are not in a place that we can do this successfully today without a lot of just heroic and heavy lifting. But that is the idea. And I think that's what makes them so interesting and useful.
Got it. What scares me, Josh, are these transitive dependencies and the depth at which you need to go, right? Because software is made of software, which is made of software, and it keeps going on. So any advice in terms of how people should think about this?
I mean, look, transitive or not, it's your dependency. Again, if you ship it, you support it. And this amuses me always because I have this argument sometimes where people are like, oh, we're only going to scan the dependencies we added. It's like, no, that's ridiculous. If you ship it, you support it. It doesn't matter. It doesn't matter if you added it or if something 5 layers deep added it. Like you still need to know it's there. Now, there are some challenges because let's say you have a security vulnerability in something 5 layers deep. You generally can't just go update that. You have to get everything along the way to update itself. So like that's one of the challenges we see in this space that we don't have necessarily good solutions for. But at the end of the day, like transitive or not, it's your problem. I don't care. Like stop making excuses and fix your software.
No, I love what you're saying. If you ship it, you support it. I love it. I mean, that's a very simple, effective tagline. So is SBOM a security necessity for companies building commercial software?
It's becoming one. I think if you look at a lot of the regulatory landscape and what it's starting to look like, we're seeing SBOM demanded in more and more places. For example, like in the United States, you've got the FDA is mandating them for device manufacturers. We're seeing the federal government is they're saying if you're a vendor to the federal government, you need to supply SBOMs. I mean, we all know how that works. It's an unfunded mandate. So it's,
This is the executive order.
Yeah, right, exactly. Well, there's the executive order, but then we've got like CISA has their SSDF questionnaire. You've got, I forget which organization it was, but they put out guidance that said like every software vendor has to provide SBOMs to whoever you're selling software to. We're seeing things coming out of Europe. There's like the CRA, you've got NIST 2. They're doing these regulations that are requiring SBOMs. And it's funny because we chatted the other day and I said, oh, I forgot what CRA means. And I'll make sure I know. And I've already forgotten. So
Cybersecurity Resiliency Act.
Thank you. I always forget
Cyber
that.
Resiliency Act. I don't think it is. Yeah.
Yes. But like that's one of those things that are telling vendors in Europe, like you need an SBOM. And so again, I think back to my initial controversial statement, people don't do things unless they have to. And I think SBOM is one of those. Like it's easy to say, oh, we should all make SBOMs. And we'll all say, yes, that's a great idea. But they're not free. Like you have to have infrastructure to do this. You have to have a place to store them. You have to have a way to distribute them. And so when the hard problems show up, it's easy to be like, we'll do it later, right? And then later never comes. Versus when the government starts saying you have to absolutely do this, now it changes. Now, that also, though, the way these are written, is you also need SBOMs from your suppliers. So like if I'm selling you software that you as a company are going to say, give me your SBOM, and then you give the SBOM, you pass it on along the chain. So that's one of the things that we're starting to see in this space.
And do you see by maybe I don't know if it's a controversial question or not, and maybe a dumb question even. Do you see publishing SBOM as a security threat?
No, I don't think so. I mean, this is one of those things you'll get people arguing back and forth about it. It's intellectual property, what software I have, that the bad guys could look at it and figure out what's going on. I think security through obscurity has never worked. And I think this is the same thing. I mean, you can maybe make the intellectual property argument where you don't want a competitor to know what open source you're using or something, but I feel like it's weak. But regardless, you don't have to publish an SBOM in public. You can just give an SBOM to, whoever you're selling to your customer and tell them like, this is IP, you can't share it. And that's just the way it is. I mean, any sort of business relationship, you got NDAs, we've got the protection of intellectual property, that's not uncommon. And I think this is actually one of the challenges SBOM has had is in the early days when the NTIA in the US was behind SBOMs, they put out some guidance that sounded like you had to make them all public, which people got a little up in arms about. And that's not what their guidance was supposed to mean, but it's kind of how it looked. So there's lots of facts and things that say, that this isn't true at all. But I mean, you know how things go. It can be tough to get those updated sometimes.
How do you generally rate the maturity of our industry, especially dealing with these risks?
I have a great question for you to that will judge this. Is there a compliance standard I can follow that if I'm brought into court and sued because I have an incident, I can say I followed these best practices, I did the right thing, there's no case here?
There is no such thing because every compliance report is co-signed, right, by the auditor who's supposed to evaluate risk and by the management who's supposed to state that I provided everything to the auditor that, on which they're basing their evidence on. So it's a shared responsibility and each can escape the other.
Right. And I think that's one of the problems. I mean, there are industries where you can show evidence that you've taken we'll say, correct precautions. And when the accident happened, it was not because you weren't doing what you were supposed to do in terms of like, say, human safety or something like that, right? Versus that's where you get into kind of negligence versus just expected failure modes. I feel like in the world of security and in IT security, we're still immature enough that we don't have the ability to say, if you take the standard and you follow these instructions, the odds of you being breached are going to go down significantly. Like you see the same thing with insurance. How often do you see your cyber insurance provider say, you have to follow this standard? Because if you do that, like you're not going to get breached as often. And we don't have that today. I'm hopeful we will get them, but that's kind of the thing I keep in my mind all the time is the industry, I would call it mature, when we have guidance that we know works. And I feel like a lot of our guidance often feels like, kind of chicken bones and voodoo.
So maybe, okay, I see your point. So your point is that I think it goes back to the first comment that you made. So your point is that if with the proper regulation, and I'm using the word regulation loosely, and compliance, essentially an oversight body, your argument is that a lot of these problems can be mitigated. Is that a fair thing to say?
I mean, hopefully. Now, I'll point at PCI as I think something that has shown promise. I feel like before PCI was as widespread as it is, you had horrific security breaches where people, I remember a decade ago, I feel like I got a new credit card every 3 months, right? And I don't think I've had mine replaced in more than a year at this point, which is, it's pretty nice because it's a pain in the butt every time you get a new credit card. But I feel like PCI is one of those examples where some of this guidance appears to actually be having a positive impact on what's going on. Now, I'm sure I could find plenty of people to argue with me that PCI is stupid and it doesn't do anything. But like, I've known, I have a story I can tell. Is I remember back in my early days, this was early 90s, I was working as an intern at a very tiny ISP. And there was a local marathon that was like, we want people to be able to register online for the marathon and enter their credit card number, and then we'll charge them. we were just writing credit card numbers into a SQL database. Like there was no HTTPS, that nothing was encrypted. And I think about that and I'm like, that's nuts. But I bet everyone was doing that. That was probably not uncommon, right? And now obviously PCI has guidance that says like, absolutely not. You cannot do any of these things. You have to encrypt the data. You can't collect entire card numbers. You know, there's so much that you have to do. And again, I feel like when I look at like the credit card industry, it feels more secure than it did 10 or 20 years ago. And so that I feel like is progress, but I don't always feel the same way about all the other guidance. Now, I'm not dismissing compliance or security standards because I have no doubt if we did not have what we have today, things would be way worse than they are. Because like as weak as some of these might be, like as non-descriptive as ISO 27001 might be. I know we chatted about that, you know, before the show. It is very loose and it is not well defined, but I think part of that problem is just we're learning, right? It takes a long time to figure this stuff out. And the other challenge is in the world of like compliance and standards. If you put out bad compliance, that's sometimes worse than no compliance. And so I think they're being very careful and measured in what they're trying to define versus being, you know, fast and loose and everyone being like, these people are idiots. We're not listening to them ever again.
No, I love it, Josh. But let me ask you this. How prescriptive should compliance standards be? Should they tell you what you should do?
I think yes. Like I love the NIST 853 guidance. I feel like honestly, I think it could be more prescriptive in many instances. I think I love FedRAMP for this reason. Like when you're trying to get FedRAMP compliance, it is very specific about what you should or shouldn't do in many cases. And I like that. And the reason being, how many security people do you know that you would just say are completely overworked and they're like running everything at 110% all the time? Right? That's every security person you've ever known. 100%. Every one of them. Yeah. And so by not being very prescriptive, by having these more descriptive style compliance standards, that puts a lot of mental strain on an already mentally strained person. And so they're going to make mistakes. They're going to forget things. They're going to leave things out. And yeah, maybe auditors will catch some of it. Maybe they won't. I mean, when you have an auditor going through, you know, hundreds and hundreds of controls, they suffer from the same sort of fatigue everyone else does where, I mean, how many times have we been there where we're just like copy, paste, copy, paste, copy, paste. Whoops, I've been pasting the wrong thing for the last 25 minutes. I've got to go fix them all, you know, because you get tired and you don't see these things.
And you're looking at a sample of 20 for a size set of 20 million records, right?
Yeah, exactly. So, I mean, that's kind of my view on that. But at the same time, every environment is different. And so it's very hard to have this very prescriptive guidance that says like, you have to do exactly this because that doesn't always work. I mean, and again, this, I'll like turn the light back on the SBOM universe. Like this is, I feel like it's very understandable in that context where if you scan 10 applications and then you look at the software in them, they might not have anything in common. Right? Because they're like so grossly different. So how do you provide guidance for those 10 things? And now the average enterprise has thousands of things running in it. Do you want thousands of different guidance documents for every one of those? I mean, that sounds maybe worse. I don't know. Maybe it's better. I can't say.
That's a beautiful argument, but I feel that you're arguing on both sides, Josh. On one hand, you're saying it should be prescriptive. On the other hand, you're making a case that it cannot be prescriptive.
Yes, I'm doing exactly that. 100%.
Okay.
I'm not.
No, but I love it.
Here's how I look at it though, right? As the person that's trying to secure things, I want very prescriptive guidance. I have customers that like Anchore has their a product that does SBOM management. We do like vulnerability scanning, policy enforcement, things like that. And our users say like, I don't want to figure this crap out. Like, give me a policy that does what I want it to do. They want something that has all the rules in place and they don't want to have to like read something and interpret it and figure out what it means, right? So as a practitioner, I want something to solve my problem. But now, as a vendor or as a person existing in a world where we're defining some of the compliance standards, I understand the challenges here. Now, how do we bring both of these sides, you know, kind of together in the middle? Yep. I do not have an answer for that, but I think it is what we have to do. We have to be more clear Because if we don't have good guidance that really tells people like this is exactly what you need to do and this is why you need to do it, I think we don't see the kind of progress we want to see.
If a very smart person like Josh does not have an answer, who do you think has an answer?
I don't think anyone does. I mean, I think this is one of the challenges you have when you have like a new industry. I'll tell you, I told you this story early, but I'll tell it for the audience. So there is a story I have about air brakes on trains. So back in the day, when you see like the old-timey trains, they had those like wheels on the top of the cars. Those were brakes. And people would run back and forth on top of a train and they would spin those wheels to stop the train because every brake was connected to one of those wheels. And people would obviously fall off the train. You fall off the train, you're dead. Like that's it. And it was horrific. And there were lots of accidents. And then someone invents air brakes. And air brakes obviously solved this problem because now people aren't running back and forth on top of trains. It took 80 years from the creation of the air brake until the regulators finally said like, that's enough, like air brakes. You're using air brakes. No more people on top of trains. And how old is IT? I mean, granted, C is like 50, so we've got 30 more years to go there. But a lot of the stuff we're doing, it moves so fast and it's so hard to keep track of. And so that I think is one of the extra challenges we have is it is really, I mean, like SBOM is a great example. I mean, what, 2-3 years ago, most people have never even heard of them. And now it's something that gets talked about all the time. Well, what does that mean? How do we turn some of the things we can do with SBOMs into, useful compliance, into useful regulations? And so we don't know today, but now this is part of the like human experience of being in any field is we have to learn, we're going to make mistakes. We have made mistakes. We've made a lot of mistakes, but that's how it is. But what we need to do is we need to make sure when we make mistakes, when there are challenges, when things don't make sense, that we take good, honest looks at them and say like, let's figure out what happened and let's make it better. I do think in a lot of the computer security world and cybersecurity, we do not do a good job of learning lessons and making changes in the future. I think we could do better there. And I think that would help a lot.
And what do you say to people that this idea of compliance, right, or conformance stifles speed and innovation?
I mean, it probably does, but that's okay too, right? Because you need some level of sanity. I mean, like move fast and break things is fun when you're a social media site. It's not fun when it's my pacemaker. I think there's different levels of how things work in the industries you're in. Like, I don't want my food manufacturer trying random things for flavors that no one's ever eaten before and we don't know if it's safe or not. Like, that's terrifying, right? I mean, honestly, if you look at food at the turn of the century in the early 1900s, it's kind of what they did. I'm just like, just throw some of this in there. It'll probably be fine. And it was horrifying, right? There were like people literally died. And so I think that's one of the things we have to start reconciling is now that everything is becoming technology. I mean, you can't hardly buy a thing that doesn't have a microprocessor in it now. And so what does that mean? How do we regulate it? How do we make sure we don't kill a whole bunch of people? And unfortunately, an enormous amount of regulation is written in blood. And I would like to say that IT will avoid some of that, but I don't know. I mean, I think history says we're going to learn some lessons and some of them are going to be pretty ugly.
Okay. With engineers and product guys, right, and even security, compliance gets a very bad rap. Why do you think that is the case?
Oh man, it's totally our fault. So the stories I like to tell is I remember back in the days when I was a young security person at mostly at Red Hat, is we would just show up and be like, hey, security's here, everything's going to be fine. Like just listen to us and we'll solve your problems. And developers were like, what are you even talking about? Like none of this makes sense. You don't know what you're doing. And I think security had this overinflated sense of importance for a long time. And I think we've kind of ruined our reputation quite a bit. And so now when you say like, oh, the security people are coming, they're like, oh, these guys. And so I think the problem isn't compliance and the problem isn't developers. I don't think anyone wants to develop bad code. I think developers want to do things that help the company, like being compliant helps the company. You can now sell to different markets. You maybe have cheaper insurance, whatever. There's a million things that it can be. And so I just totally think it's like that whole attitude of security thinking they're smarter than everyone, they're better than everyone, and just like, get out of the way, I'll do it. And like, no, that's not how any of this works. And so I completely blame us. It's a human problem. We screwed it up. And I mean, it's funny because this is something I'm very aware of. And when I went to Anchore, I'm like hat in hand all the time when I go try to talk to someone, and so I'm like, okay, here's what I see. Like you tell me, like, does this make sense? Are we doing the right thing? In our yearly compliance training or our yearly awareness training that I put together, which I do it myself because like all the awareness training I found just infuriated me, and I'm like, screw it, I'm doing it on my own. And basically I keep pointing out, I'm like, look, if something happens, just come tell me. I'm not going to yell at you. I'm not going to make you feel bad. Like I promise you, that is some security people you may have worked with in the past. I am not going to do that. And I try my best to be as approachable and polite as I can. I tell people, like, if you're buying your parents a computer, you can ask me for advice and I will help you. And a bunch of people have done things like that where, they'll come ask me like, oh, hey, I need a password manager for home. My kid's going to college. What kind of stuff should I do? And I think that's part of it is like, I work really hard to build that goodwill because someday I do have to show up and be like, we have to do this horrible thing you don't want to do. We have to, delay this release. We have to fix this package. And it's going to suck and it's going to break a lot of stuff. But when you're a friend and you're working together, that's an easier conversation than when you're an adversary and they're just trying to get rid of you.
No, beautifully said. So to the security guys and gals that are watching this and your peers, you're basically saying, get off the moral high ground. That's what you're saying.
We have no moral high ground. Yeah, we're all on the same team. Like just work together. And I know that's easy to say. It's hard to do. And especially if security teams have been burnt in the past, or I'm sorry, developers have been burnt in the past by security teams, it can be really hard to rebuild that trust. Like it's really tough for sure.
You have said before that SBOMs, you see SBOMs as an observability tool. Can you explain for our audience?
Yeah, for sure. So ironically, this kind of harkens back to Elastic, is Elastic was used for observability of software. What I mean by that is, let's say I have an application running, and I'm going to pay attention to what the application is doing. Like, what does the RAM use look like? How much processor is it using? What is the disk usage? Like, how long are function calls taking? There's lots of things you can do, right? You collect all this data, and then you can look and see like, oh, we see this part of the application gets slower when this part of the application does this one thing, right? Because you can start connecting all these seemingly unrelated events. And it's super interesting and super powerful. And I think like software bill of materials feel very similar to me, where we can start looking at our software, and it's not the executing part of it, but rather the kind of development and how it's changing over time. You can look at something like, for example, we could say, we're seeing developers are changing this component on a regular basis. Like, what's going on? Why is that happening? We can say, we're seeing like this new dependency flowing through our systems. Like, let's understand what that means. There's so much information we can start extracting from this, and it intrigues me. Like, we don't even know what we can do with it yet. I mean, I think this is one of the things I learned from the big data universe, is sometimes you don't know what you don't know until you start poking at things and you look at trends, and you can look and say things like, something weird is happening at 3 a.m. every day in this application. Why is that happening? We could do the same thing with like an SBOM. You could say like, why is it that on the 15th of every month, we see all these dependencies start to change, or we're seeing more dependencies added on a Tuesday or whatever, like weird things. And then we can start saying like, why is this happening? And then once we start asking those questions, we can start better understanding what our development environment looks like, what our supply chain looks like. And then we can maybe make changes, or maybe just be aware that this exists at all.
That's brilliant, Josh. I called you a Linux dude. What did I call you? SBOM dude.
Yeah.
I'm a security dude, and I'm going to add a data dude to it.
Yeah, I'm an armchair data nerd. I love data. It's one of my favorite things. It's so much fun. Like, one of my favorite things I do kind of on the side is I have two projects I like to do, where I take all the CVE data and I put it into Elasticsearch, and I create these like bizarre graphs. Like, actually, we're recording at the end of February, and a couple days before we recorded, the Linux kernel added 700 CVEs to the database. So when I'm looking at it, like, takes this huge spike up. I'm like, holy crap, what just happened? And then, of course, thanks to Elasticsearch, I could figure out exactly why that happened, which is cool. And the other thing I like to do is I take as much open source data as I can find about open source projects. There's this thing called Ecosystems. A fellow named Andrew Nesbitt runs it. It's this like public API. It's an awesome service. And I download like as much metadata as he has about all the open source projects. And then you can watch them grow. Like, there's literally hundreds of millions of open source releases in the world. There are tens of millions of open source projects in the world. Like, it is mind-boggling numbers. And you can't, like, as a human, you can't wrap your head around it. But you can look at graphs and be like, oh, look at it. It's going up exponentially. That's great. Like, what are we going to do about this? And again, though, I think that's where like the whole SBOM universe comes into play, is we can take this data and we can ask questions about it. And we can say things like, okay, I have a dependency that's used by me and 2 other people. That's weird. Like, let's figure out what's going on here. Did I just get hacked? Have I downloaded the wrong thing? I don't know. And so that's where we can start combining all this data and really having a lot of fun with it.
And I just want to unpack what he just said, because I think it is very profound. What you're basically saying is SBOM is loaded with signals.
Oh, yeah.
And
yeah.
it is, and we are still just trying to figure out what can we infer from those signals, and it can be huge. That's the point.
Yeah, for sure. For sure. I mean, I think today the most common use case I see is just scanning for vulnerabilities, where you say like, I'm running version 1. Version 1.5 has these vulnerabilities and they fix it in version 1.6. So I should upgrade to version 1.6. But there's so much more going on. There's so much fun data you can look at. Like, how many files are there? How big are they? Where did this stuff come from? Like, one of my favorites is we have this concept in the open source scanner SIF that Anchore works on, where we call them known unknowns, where you have a container, right? And there's obviously stuff in the container. And you've got like, the operating system packages, let's say RPMs or Debian images. You've got like the NPM stuff you installed. So we can look at like all these things that got installed as part of your expected development universe. But what about this other crap that isn't claimed by NPM or RPM or any sort of package manager? Where did that come from? And sometimes you look at it and stuff like, oh, a developer accidentally copied a bunch of crap from their home directory into this SBOM, into this container. And again, that's like some of the fun data we can unpack and unwind and look at. And I have a funny story about that. Actually, was when I was at Elastic, we had a release one time where one of our customers, we were not scanning with it we were not running an SBOM scanner at that time. This was way early days. The SBOM scanners didn't even exist, honestly. Where a customer basically, sends me an email and they're like, hey, why did the number of dependencies in this thing you released double? I'm like, what? What are you talking about? Mm-hmm. And I went and looked. I'm like, oh, holy crap, they did. And it's because the developer accidentally packaged up all the development dependencies with the production build. And I'm like, oh my goodness, we look like idiots, And of course, I made sure we weren't going to do that again. But, it's that kind of stuff where you can start looking at this and saying like, our dependencies doubled. Why did they double? What have we done? We screwed something up. Probably.
On a sidebar, are we having a discussion around CVSS, the CVSS scoring? I mean, the Common Vulnerability Scoring System, right? Is there a big debate that is going on right now?
I mean, there's been a debate for like a decade. CVSS. So we in the world of vulnerabilities, we love to crap on CVSS. It's not really CVSS's fault. So CVSS is a scoring project from first.org, which I suspect a lot of people are aware of first. They do a whole bunch of compliance stuff, but they have the CVSS, Common Vulnerability Scoring System. And this group has created like this set of, I guess, metrics where you can say like this affects local network. You have to be on the local machine. It has, I can't remember all the terms even now for it. But anyway, you kind of click all these boxes, you say what the impact is, like does it impact confidentiality, availability, things like that. Very, very normal GRC things. And then it gives you a score. And the score is intended to give you some sense of severity. And of course, you're supposed to apply this to your environment and understand how you're using an application. Because like a good example is if I'm, writing a web server, now we're talking like network access versus if I'm just writing like, some tool that runs against local data once a day, like it never touches a network. Those are very different situations. And the CVSS scores are going to be drastically different in those two environments. Yep. Now, there is a project called NVD, the National Vulnerability Database, that NIST runs, and they take CVEs and they give them CVSS scores. And we hate their scores. We hate them so much. And everyone knows about them. But what happens is, and this is, I partially blame NVD for this, I partially don't. Like they assume the worst. They don't know how you're using that library, so they just assume people are like parsing data off the internet with it. And so they obviously, the scores are very high, much higher than they need to be. And so I think CVSS gets a really bad rap in that regard, because what we actually don't like is we don't like the way NVD is scoring things. The problem isn't CVSS.
Got and First.org also publishes a model for exploitability, right? A 30-day exploitability.
The EPSS.
EPSS,
Yes.
exactly. So does that help? Does that help address this issue?
I think so. I mean, so I think where we are right now in the world of vulnerabilities is everyone is trying to find ways to prioritize this stuff. We used to just use CVSS, and I think it has become abundantly clear that CVSS is a terrible way to prioritize vulnerabilities. And I suspect all of the people who work on CVSS would agree with that statement 100%. They'd be like, stop using this to prioritize vulnerabilities. Like, please stop hating us. But so EPSS is, they're looking at all of this kind of public data, and it creates a score between 0 and 1 of how likely is it that this vulnerability is going to be exploited in the next 30 days. 1 being 100% because there is a public exploit, and obviously 0, nothing is 0, but you can be very, very low. And the number of things that are highly ranked is very low, because if you look at all of the data that's out there, it's like 3% of vulnerabilities are ever exploited in a given year. Like, the number is very, very low, yet we're running around crazy over every vulnerability all the time. And so the intent of EPSS is to start giving us this sense of like, how important is it going to be for me to fix this vulnerability? Because the other thing that I think this also makes people hate security people is there's this like notion of 0 CVEs that comes and goes every couple of years, and it's hip again. 0 CVEs is just a fool's errand, right? If that's your goal, like, you're going to hit 0 CVEs, but you're not going to do it in the right way. This is 100%, that situation where you just have these perverse incentives, like the Cobra effect is one of my favorites, right? Where it was back in the many, many years ago, you had the British government telling, folks in India, if you bring us a dead Cobra, we'll pay you. Well, the Indians, being the entrepreneurs they are, they started breeding Cobras. And so the Cobra problem was way worse, not better, because now, and then of course, when the British government found this out, they're like, oh, we're not paying anyone. They just let all the Cobras go. So now it's like way, way worse than it was before, and I think the challenges we have now is just, how do we take all this data? How do we take everything we understand, and how do we start making good decisions about it? And we're learning. I mean, we have a long way to go, but there's definitely a lot of interesting things happening in this space. So I feel like it's better than it was a couple of years ago, but I wouldn't say it's a solved problem at all.
Okay. I want to come back to SBOMs. Why are SBOMs so difficult to generate?
Because software is complicated. I mean, it's getting easier. There are many scanners that are doing a nicer job. We're seeing some of the packaging ecosystems are starting to just make SBOMs for you. When you like, Python is one of these that they're just starting to add that ability into their build tools, which is 100% the right way to do this. You've got other environments. So like, for example, if you have C code, like, where did that C code even come from? You probably don't remember. I mean, I'll never forget, I worked at a company fresh out of college that we had a C library in the product. And one day I was like, where did this come from? And they're like, no one knows. Like, we just have it. Don't ask questions, build it. It goes in. And it's one of those things like, what is this? Where did it even, and in C, that's much harder. Now, there are a lot of tools like the Anchore's tool Sift makes it very easy. I'm not saying it's perfect, but we're working really, really hard to find more and more things, and it's constantly evolving. And I think making an SBOM today is 1,000 times easier than it was 5 years ago. And I have no doubt in a couple of years, it'll be 1,000 times easier than it is now. Like, we're making a ton of progress in this space. So it's easy to crap on SBOM and say, oh, the scanners all suck and the data's bad and whatever. Like, to a degree, but it's getting better. And this is definitely one of those instances where, like, if you run an SBOM scanner and it doesn't find something, report it. It's a bug, right? Report it as a bug. And from our perspective, we love those bugs. Like, yeah, we're totally going to figure out why it did that and what we can do to make it better. And now at the same time, there are things that are very complicated that you're never going to be able to scan. And there's a project at the Linux Foundation called the Yocto project. This is where they build like an embedded version of Linux that you can run in IoT type stuff. They have instrumented their whole build system to output SBOMs as part of the process, because they know the thing they output is this just unintelligible piece of binary stuff Like there's nothing to scan, there's nothing to figure out. So they've said, we're going to do this for you and we're going to give you an SBOM so you know exactly what it
That's
is. And
very
again, if you build it, you support it, right? Or if you ship it, you support it, I
yeah.
should say.
No, that's beautiful because that was going to be my follow-up question. So if I compile, especially for compiled systems, if I build a binary from Go and delete the Go sum and the Go mod, what do you go scan against?
So actually, Go has done an amazing thing. Your example is really good. So Go has augmented the compiler to add in information about which dependencies were included in that build. Now, granted, you can turn that off so you have smaller binaries, but for most of us, we want that data. So actually, when SIFT scans Go material, we get way better information out of that than we do out of almost every other ecosystem that exists because the Go compiler puts all of that information into the Go binary itself. It's amazing.
Oh, that's beautiful. So I want to come back from a compliance perspective, Josh. How, and maybe it's from a security perspective as well. From a security and a compliance perspective, how do we accelerate this adoption of SBOMs? What can we do as practitioners, and what can companies do?
I mean, I think at this point, companies need to follow the law. Like that's I don't think the question is how do we accelerate it? It's going to be how do we do this in a way that keeps us compliant? Because it's coming. Like every industry is starting to worry about this stuff, and I think we're all going to need it. And now, as I'm sure you're very aware, Raj, as humans, we love putting things off until the absolute last minute. Like it always amuses me when there's some new compliance standard is being enforced. My favorite was what DORA just went into effect in the EU. And I had someone email me like a week before DORA was supposed to be on, like, oh, DORA's coming. What do I need to do? I'm like, you need to go back in time. That's what you need to do. Like, you're not getting this done in a week. But I think from the SBOM perspective, it's really about, understand the industry you're in, understand some of the compliance requirements and expectations that are coming your way. Like none of this is new. We have years to prepare. And you know what's coming if you're in the industry. You pay attention. And so I think what it really comes down to is just understanding your environment and then finding tools that will help you create the SBOM for the thing you have. No one is saying you need a perfect SBOM. They're saying you need an SBOM, right? And it needs to be good enough. I mean, this is all compliance, right? Like there's no such thing as perfect security. You just need to make sure it's good enough to pass the audit. And SBOMs are going to be the same story. Like there are lots of tools. There's lots of open source tools. There's lots of vendors working on this stuff. Like I work for a vendor working on this stuff. We even have an open source tool. We try to make it easy to use. And so like step one is just start doing it, right? Just go make an SBOM, find a scanner, run it on your stuff and take a look and see what you get. And then of course there's iteration and we need to improve and we need to figure out like where do we need to be to make sure that we're following this regulation that's being forced upon us by Europe or the FDA or our large customers or whoever. And it's less hard than it was even a year ago, I would say. So if you kind of took a look at this and you were like, this is ridiculous, I'm out, I would take another look. I think things are getting better fast. And I have no doubt in a year or two, it's going to be even better than it is today.
You ship it, you own it.
First, yes.
That was your statement.
You ship it, you support it.
You support it. Okay.
You confused me.
Okay.
Yes. I mean, yep.
What do you see as the role of generative AI, large language models, small language models in software supply chain?
I mean, I don't know. I wonder this a lot, actually. There's an article I just read this morning where NVIDIA actually has a tool they call Morpheus. And actually, Anchore is in their tool chain of this thing. But what Morpheus does is they scan like a container image because NVIDIA has this thing. They have this like big container registry for all this generative AI work they're doing. And they scan these images and then they get the vulnerability list, right? And they built this tool called Morpheus that basically looks at these vulnerabilities. It goes out and collects as much information as it can to put together some, detailed descriptions of what they are using their GenAI. And then it can also basically look at the thing it is in and make some determinations about how is this piece of software used in the larger container, in the larger, product or project or whatever it is. And then it tries to prioritize this stuff. And the intent isn't to like automate the fixes. It's to help humans figure out like, what are the things I need to know? And I feel like automating fixes in a lot of cases, like we have Depend About at GitHub. That works great. that I think is less interesting now versus being able to use some of this technology to just help weed through the trash. Like there's so many CVEs, there's so much vulnerability information, and it's really hard to figure out what some of this is. And so I'm really intrigued by what we can do. But now, that said, one of the challenges of security is there are certain things we have to not miss because they can be catastrophic. And I also think in many instances, some of the generative AI we'll say is not predictable or accurate enough that I would necessarily feel comfortable only using generative AI. But I think when it comes down to trying to understand and unwind some of these technical details, it has some, I think there's purpose. I think there's potential there. So we'll see. I'm very interested and I'm hopeful, we'll say, because goodness knows we're all drowning.
I love your example. So essentially, I think you are saying generative AI, especially in the world of SBOM supply chain, can help you narrow down on the signal to noise ratio, because which is a huge problem. Okay.
Yeah, I agree. There's so much noise. It's so hard to figure out what is and isn't noise in this space. And I mean, I feel like most of the tooling everyone is working on, goodness knows I am, like the tooling is more about at this point weeding out the noise than anything else.
Got it. We are approaching the end of the segment, Josh. For the new person who wants to enter into this field, right? What is your advice to them? How can they become the next Josh Bressers?
Oh goodness, don't do that. I mean, in all seriousness, that's one of the funny things that I've talked to many other geezers about is like, we didn't have any education. There were no certifications. There was nothing. Like it was all trial by fire. So like the way I got to where I am will never exist again. And goodness knows should never exist again, because like it was security. This all was so new and it was so weird and so crazy. I mean, there's a lot of good ways to learn about anything you want now, right? There's so many working groups. There's all these communities and places like Reddit and Discord, and there's Slacks. There's local university meetups. There's so much to learn from this. And I feel like step one is just, you need a foundation in technology, right? If you don't know how a network works, you cannot do network security by definition. Like that is the reality. Whether you want to believe me or not, that is how it works. So you need that foundation in just technology and the things you're interested in. And likewise, if you're interested in something, it's not a chore, right? You like learning about networks. You like learning about microprocessors. You like learning about, secure development, whatever. And then I think it's a lot of just meeting people and having discussions and figuring out what you can learn and how you can learn it. I learn more from the people I know than from anywhere else, because someone will send me a link and say, hey, look at this article I found. Hey, you should read this book. I really liked it. And I think the people you meet is the most important aspect and this is true of any field. This isn't just security, but the people I know are far more valuable to me than almost anything else is, because I can ask questions. I can teach them things when I learn something new. I mean, it's very human that when we do a thing, we want to show someone, like, who can I show this cool thing I just did? It's in that I feel like open source is very much that of like, look, I built this cool thing, everybody. Isn't this neat? And so you get that. And I think like even open source is part of the story. There's so many open source tools. There's so much open source stuff. Like you can get involved, use it. Like something like using a tool and writing a blog post about it, even if there's a million blog posts, like you will learn as you write, and there is someone who will find value in that. And so I feel like this is a non-answer almost, but there's so much going on. There's like no one way. Like, yeah, you can go to school, you can go to meetups, you could read books, but at the end of the day, all of that is really going to come down to the people you meet and the people you know, I think.
I think that's actually a great answer. And any call outs for any specific open source projects in security or compliance?
Well, I mean, obviously, Sift and Gripe are the two that help feed my family. So I like them a lot. But then I think from kind of just a compliance perspective, you've got all of these organizations. Like I help out at the OpenSSF. And now, granted, I complain about the OpenSSF all the time. I'm not saying they're perfect. And we could do a 2-hour podcast just about my complaints about OpenSSF projects. But there's all of these groups, like FIRST is another good example. Like you can join FIRST, you can get involved, you can be a part of this, and you'll meet people along the way, which is part of the fun. And so there's a lot of that. But when you look at just kind of open source, it depends on the area you're interested in. I mean, from the perspective of like, SBOMs and supply chain and all of this, you've got, there's these tools. There's a tool Google's working on at the OpenSSF called Guac, GUAC, which is like, why you can't even search for that.
User artifact composition, something like that.
Well done.
Yeah.
Yes. It's funny because the guy who created it, I'm like, Brandon, you can't name something guac. I cannot find this. But it's a great way to, collect all this supply chain information. You can visualize it and you can understand it better. And it's really, really interesting. And there's, oh goodness, what else is there? There's a really cool project I'm starting to work on at part of the SBOM Everywhere Working Group at the OpenSSF, where we're calling it the catalog. Very well. We're very good at naming things. But it's what we're doing is, in fact, we're using GenAI as part of this project, where we're trying to find all of the like SBOM related tools and SBOM adjacent tools. Then we use GenAI to help write descriptions and we find some capabilities. So we're talking about literally hundreds and hundreds of things at this point. Like we're past the point where humans can actually do this easily. GenAI creates the descriptions, and then it's a website that you can like say, I'm looking for an SBOM tool that generates like SPDX SBOMs for Python packages, and it'll show you all of the tools that can do that thing, right? And then there's also like put some fancy buttons in it so you can like make edits and correct text, and because we know the GenAI is not going to get it right every time, and that's okay too. Like our intent is we'd love to just generate the stuff as humans go and fix it for us, but we'll get there. I mean, it reminds me of what's that law that says the easiest way to get isn't to ask a question on the internet, it's to give the wrong answer and someone will correct you. Like it's exactly the same idea. But I mean, oh man. And I guess the other piece of that I would say is I'm an avid podcast consumer. And so, I mean, I call obviously this podcast, and I'll assume people are already subscribed if they're listening, but it's a lot of fun. But there's a handful of other things I love. Like I like a lot of just random space podcasts. Like Universe Today is one of my favorites. I love Paul Asadorian has Paul Security Weekly and like his whole universe of that. Like that's super fun.
Yep.
They're a great crowd. I've been on that one a couple of times and it's always so much fun. But then there's like one of my favorites was Yahoo Paranoids used to have a podcast that was just like, it was so good. Unfortunately, that one's fallen away. But there's so much media. There's so much fun stuff. I can't even pick one, Raj. Just there's too much stuff, and that's part of the fun. And again, this is where knowing people. I have people come to me all the time and say, "Hey, you should listen to this podcast." Like, in fact, it was one of my favorites right now. It's called Security Cryptography Whatever. And it's incredibly technical. It talks about cryptography all the time. I don't even know what the heck they're talking about half the time, but it's fun to listen to. And that one was like, I was on Paul Asadorian's show, and before we hit record, he's like, "Oh, I found this podcast. You should listen to it." And I'm like, "Holy cow, it's awesome! I love it." And that's one of those things. Like, there's just so much cool stuff, and ask the people for more cool stuff because they're gonna tell you what it is.
I think we should get this list from you, and we would love to sort of put this as part of the podcast so that people can see this, Josh.
Yeah, for sure.
You have so much information packed there. One final question, and I think you sort of already answered it. Other than the podcast, do you follow? Do you read books? Read any books? Follow any authors? Follow any mentors? Anything that you want to give a shout out?
I read so many books. I love reading. It's super fun. The one shout out I would give. So I read a lot of technology books, obviously. And the one I would say everyone should go read if you haven't read it is Joseph Menn wrote a book on the cult of the dead cow, which is phenomenal. And it was really good. And that was my growing up as a child, like everything in that book. I remember all of it, which is really cool. But then I also like to not read technology books necessarily. Like it's funny. I had someone once ask me like, what's the best management book you ever read? And I said, Moby Dick. He's like, what? I'm like, I'm serious. Like, read Moby Dick and pay attention to like the management structure on that boat. Like, it is horrifying. Like, it is the perfect example of what not to do, And so I think there's a lot of value in things like that. Like, I love reading science fiction. I've been reading The Wheel of Time for like years at this point, but I'll get through that someday. But then, it's just, again, everything I read is because someone I know said I should go read it. And that it's fun because then also when I read it, I can go talk to them and be like, "Oh, I read that book you told me to read. And this is what I thought about it. This is what I liked. This is what I didn't like." And it's super fun.
Then I will send you a book. I don't know if you've heard of it. Peter Senge wrote a book called The Fifth Discipline. Peter is considered the systems engineering guru, but there is nothing engineering about it. And it sounds more philosophical than engineering. And I would love to, so for you to take a look at that book and, give us some feedback.
I'm excited. Yeah, definitely send it along. Again, see, this is the fun, Raj. Like, people tell you things and it's way more interesting than trying to find it on your own. I love it.
Josh, this has been super, super fun conversation.
Yeah, it's been great.
Thank you very much.
Awesome. Thank you, Raj.